right, now let's take the same sets A and B and simply change the function. Now to make it more obvious what I changed, I highlighted it in red. This time we have two elements in A mapped to the same element in B, in this case 4. So is it true that this is still a function? Well, we know that it's still a subset of A cross B because everything on the right-hand side of the comma is an element of B, and everything on the left-hand side of the comma is an element of A. So it's true this is obviously going to be a subset of the Cartesian product. Next, we need to check our second criteria. Is every element in A mapped onto something in B? And the answer is yes. There's everything here, 1, 2, 3, and 4 are in fact all here. There isn't like a missing 4 or like an extra element 5 that doesn't appear in A. So yes, this is true. Everything in A, all of these elements are mapped onto something. So we got to make sure everything in blue appears here too in the function. Okay, the very last thing to check is everything in blue mapped only once onto something in the codomain, into our B? And the answer is also yes. 1 only appears once in our function, 2 only appears once in our function, 3 only appears once, and 4 only appears once. That's pretty much what this is asking. If you still can't see what I'm talking about, let's draw out these sets. Okay, so I've drawn out our two sets A and B, and I've highlighted our 4 here, because that's obviously what people are going to be wondering. Okay, so let's see. Clearly, it's a subset of A, or sorry, before we do anything, let's draw out this function. The 1 maps to a 2, so we take an arrow from 1 and draw it all the way pointing to 2. Similarly for 2, we draw it pointing all the way to 4. We draw an arrow from 3, also pointing to 4. And then we draw an arrow from 4, pointing to 8. Okay, so this is our function, these arrows. So we can see clearly it's a subset of the Cartesian product because none of the arrows leave any of these sets. All of the arrows stay from one set and go to another set. Fantastic. Is there an arrow pointing from every single element in A, which is what this condition is? And that is true. There is every element in A, 1, 2, 3, 4, have an arrow pointing from them. They're being mapped onto something in B. Finally, exactly 1. Is there exactly 1 arrow pointing from our elements in A onto something in B? And the answer is yes. There's only 1 arrow from 1, 1 arrow from 2, 1 arrow from 3, and 1 arrow from 4. So this is in fact a function. People oftentimes might get this confused and think, well, 2 and 3 are going to the same thing in B. And that's true, but our definition of a function doesn't really care too much about the codomain. The main thing this is focused on is going to be the domain itself. We have to make sure everything in the domain is mapped, and everything is only mapped once. We don't care where they're mapped to, as long as everything is, and everything is only once. So that is why this is in fact a function. Because once again, this definition is a lot more heavy on our domain, our A. It's not as strict on our B. It doesn't care as much about our B.